In this video, we will be learning how to do phantoms with a two-sample t-test as our test. So first, we got to identify our two samples. Our B is our buy right fish store, and our F is our fish friends fish store. So now the U of B is 3.40 inches in length of fish, and the UF is 3.46 inches in the length of fish. And now these two are both our parameters of interest for these two samples. And now moving on to our ho and our ha. Our ho is that these two different stores are equal, and our ha is that our fish friends will be greater than the buy right. So our assumptions, we have to assume that both samples were randomness all around. And we also have to assume that neither sample is large enough to assume normality. So we have an n value of 8 and an n value of 10, and those are both under 30. So based on CLT, we have to assume that neither of those we can't assume normality for both of those, so we will proceed with caution. And our test is our two-sample t-test, as I stated earlier. And finally, we're going to actually execute this, and our formula for this is x bar of b minus x bar of f all over the square root of the sample standard deviation of b over the n value of b, which is the sample size, and that's added to the sample standard deviation of f all over the sample size of f, and all that is equal to t. And so plugging in our numbers, we have 3.40 minus 3.46 all over the square root of 0.434 over 8 plus 0.558 over 10, and that's all equal to our t. So with that calculated, we get our t value of negative 0.2586 and our degree of freedom of 7 because we subtract 1 from our lowest sample size, which is 8, just to be conservative with that. And so with this being said, our p-value comes out with our degree of freedom in our t-test. We get our p-value from our t-chart to be 0.3996. So from here we have to make a decision. So we fail to reject the ho based off the p-value of 0.3996, which is larger than our a value of 0.10. So now even if we had a value of lower, never mind, I was thinking of 0.01, 0.10, we gave it as much chance to succeed as possible, and it still didn't pass. I was thinking of really strict 0.01. I misread that. So yes, we fail to reject because the ho is a lot bigger, almost 4 times bigger than our highest a value that we can allow, which is our 0.1. So for our statement in context, we fail to reject the ho. That is, the mean lengths of the fish from both companies are different, or is different. And we can say this because our p-value is a lot larger than our a value.